Hello everyone, welcome to the YouTube channel Simply Solve. This is Kushan. This is the very first video of this tutorial series. In this series we are going to learn some of the basic derivations of physics, starting off with electrostatics. Now in our school days we often struggle with these derivations, so we will go step by step and solve each one of these derivations. So if you have any query, do comment in the comment section. Also subscribe to this channel for more videos coming soon. Now, when we start with electrostatics, one of the most common derivation that comes up in our mind is electric field calculation due to dipole. So, the first video here we will do calculate the electric field due to dipole on the axial line. So, this AX, so consider this AX is a line on which this dipole AB lies, and we are going to find electric field at this point P. So, electric field at this point P will be E is equal to electric field due to A, EA plus electric field due to P. Right. So we'll simply go to calculation of the magnitude of these electric fields. So EA will be 1, use the basic formula 1 by 4 pi epsilon naught. The charge here is minus q, and the distance is this AP, and this distance AP is this R plus A. Right. So R plus A whole square. Now comes the direction, quite important. So see, whenever we try to calculate direction, we take a unit positive charge over here. So this is a unit positive charge over here, and this is a negative charge over here. So the electric field will be attractive in nature. This is positive, that is negative. So the electric field will be in this direction. Right, and this is EA. Next, electric field due to charge at point B is the same fashion, 1 by 4 pi epsilon naught plus q by the distance. Now the distance over here is BP, which is nothing other than this R minus this A, right? So R minus A whole square. Now comes direction. So direction, this is a positive charge, again at point B this is also a positive charge, and hence it will be repulsive in nature and in this direction. So this is EB. Right. Now see, I have intentionally drawn this vector EB greater than EA. Right. So this comes from the fact that, see, from the basic concept of electrostatics, we know that electric field is inversely proportional to the square of the distance. Here in this case, this BP distance is less. So since the distance is less, the electric field is more. So electric field EB is more. In this case, for A, charge at A, this distance is more. Since the distance is more, the electric field is less. That's it. That's simple. So that's how we can write EB is greater than EA. Now, so the net electric field E is equal to EB minus EA. So we'll put the values over here. Q by R minus A whole square minus 1 by 4 pi epsilon naught R plus A whole square. Right. Now, so I'll take this part common. I'll take Q also. So in the bracket we are left with R minus A whole square minus 1. So in most books what they do this step and they directly go to the solution. So at some point of time this may create some confusion. So I won't skip, I'll continue doing this part. See, so I'll do LCM. So in the numerator it becomes R plus A whole square minus R minus A whole square whole divided by R minus A into R plus 3, and I'll write this square outside just for simplicity. So I'll solve this. This part remains as usual. Now this is nothing other than a plus b whole square. This is nothing other than a minus b whole square, right? So it is like a square plus b square plus 2ab, r square plus a square plus 2ar minus r square minus a square plus 2ar, right? I have taken into consideration negative sign, that is why this part is looking like that. So in this part, this is a plus b into a minus b, so I can simply write as a square minus b square format. So r square minus a square whole square, just like that. So this r square gets cancelled out with this one, this a square gets cancelled out with this one, so we are left with, I'll write over here only, so 1 by 4 pi epsilon naught into q, here comes 4ar divided by the denominator remains as usual, like that, right? So for dipole, we know for dipole moment can be given as P is equal to Q into 2a. Here you can see this 2a is the distance of separation between the two charges. So the expression can be expressed like 1 by 4 pi epsilon naught, right? So this q into 2a, from here q into 2a gets out, becomes p. We are left with one more 2 and one more r, and the denominator becomes, remains as usual, like this. So this is the part where we are done with the generalized form equation, right? But we know like a bit like reduced form. We'll do that just now. I'll write the direction. So this direction is along ax, not xa, it is along ax. So since eb is greater than ea vector, so the resultant vector will be obviously in the direction of eb, that is in the direction of ax, right? Okay. Now, so this can be written as a generalized form like this. So this is a this is a generalized expression. Now, so we'll go for the one that we know, that we are quite familiar with. So we are familiar with this one for short dipole. So what happens for a short dipole? Generally, whenever we do problems, we do for short dipole. For short dipole, this 2a value is much less than r. This r is much less than r. So under that situation, okay, I'll write the previous expression one more time like this, right? 2pr by r square minus a square, right? Whole square. Now, when this a is much less than r, in that case this r square becomes a very big value and this a square becomes a very less value. So subtracting a very small value from a very large value becomes negligible, and we can ignore this part, and this turns out to be 1 by 4 pi epsilon naught into 2p r by r to the power 4. This r gets cancelled with this one. So therefore, electric field due to dipole, for a short dipole, this is the expression that we are quite aware of, 1 by 4 pi epsilon naught into 2p by r cube, and the direction is obviously along ax. Hence we are done with the derivation of electric field due to a dipole at any axial point, right? So this is the expression. So again, if you have any query, please do comment in the comment section. Also, don't forget to subscribe to this channel because more videos are coming. That's all. Thank you everyone.